Hello, hope you're having a great day. My name is Aseem Parikh and I lead the solutions and partnerships at ONF. And it is my pleasure to be joined by Robert Soukup for this talk today. Hello, Robert.
Hello, Aseem. Hello, everyone. Thanks for having me. Nice to be here. My name is Robert, and I will be presenting the Access for the Dough initiative of Deutsche Telekom.
Right, so I'll start out by setting the context by describing the motivation and describe an exemplar implementation for open and disaggregated access networks. And as Robert said, he will then describe that Deutsche Telekom Access 4.0. Deutsche Telekom has taken the bull by the horn and is now well down the path to deploy a transformative fixed access fiber to the home, fiber to the curb network in Germany. And we are looking forward to your talk, Robert. All right, so let's get started. We are surely living in an unprecedented time, and our industry is being called upon to help digitally connect individuals to their families and friends, students to teachers, customers to businesses. The debate whether broadband is a luxury or an essential connection to the society is finally settled. And herein lies the silver lining that precipitates an opportunity from this current crisis. As social norms and business practices change, it is widely expected that these behaviors will survive the pandemic and create a new normal. As I talk to operators like DT and ecosystem players, it is clear that this emergency is serving as a fuel, accelerating the need for reliable and ubiquitous broadband access. The governments and operators in almost every nation are reacting to this urgent need for better broadband infrastructure, and investments to the tunes of hundreds of billions of dollars are being discussed across North America, Europe, Asia, and Africa. I submit that this is world's $1 trillion broadband moment. So let's characterize what it takes to support this new normal. The best served continent on the world is Europe, and that only 32% of Europeans have access to fixed broadband, as you see on the left side of the chart. Across the world, it is only 15%. And even amongst these, a large portion of those with broadband are underconnected with respect to the speed of service they get. Researchers estimate that in a few years, full duplex speeds between 300 megabits per second to 1 gigabit per second with less than 25 millisecond latency would be required for applications that incorporate AR, VR, and 360-degree video delivery. As the chart on the right shows, we are quite a ways away from this goal. But our current industry, especially the telecom industry, have faced serious headwinds over the past couple of decades. Most are having a hard time with maintaining healthy margins as demand for data grows at a higher rate than revenue. And their reliance on proprietary hardware-centric infrastructure has impeded their ability to innovate and react to new demand. And often critical upgrades and new service introduction takes months to roll out. As a result, most of the value from the network infrastructure has not accrued to the telecom operator, and this further erodes their profitability. So following the old playbook is unlikely to get operators out of this negative spiral, as you see on the screen here. So as they embark on this new broadband infrastructure build-out, governments and network operators will be ill-advised to deploy precious public and private funds, however large, without thinking through several key questions. We surely don't want to waste this opportunity and build a bridge to nowhere. One size does not fit all. What technology works in Mumbai is unlikely to work in Munich. How Switzerland connects its Switzerland citizens will not be replicable in Cyprus. Leaders should think value backwards, not technology forward. What is the right architecture? It is in the public interest to make access to architecture to be flexible, scalable, incrementally upgradable, so that it can provide services to the unconnected, underconnected for at least 10 years, ideally a lot more. This poses the question, what new services should we plan for? And that's a tough question to answer, because what is the most interesting service today may be taken over by things like augmented reality, virtual reality, or 3D video, and who knows what. So we need to be prepared to be nimble around these service requirements. Most operators today largely rely on a couple of large vendors for powering their infrastructure, but this is also self-limiting in many ways, as the rate of innovation is tied to the incumbent vendors' skills and business models. Ideally, operators would like to partner with the best of breed suppliers to stay in step with the rapidly changing customer tastes and requirements. And lastly, a build it and they will come model is very CapEx heavy. Ideally, operators want to invest as you grow models and into markets which are still not proven out. So, as ONF, a non-profit industry organization, these are the questions we have been tasked to answer by the industry's leading operators and aligned vendor partners. Over the past decade, ONF has developed and demonstrated a unique model that brings together technologies from SDN, NFV, cloud, virtualization, with value propositions of disaggregation and softwareization to deliver open source platforms that leverage white box hardware and merchant silicon. Let's look at these projects briefly. At the bottom, there is ONF has developed this over 10 years, multiple SDN and edge infrastructure platforms. ONOS, Trellis, Cord are terms which are familiar to most people in the industry today. But on top of this, we build solutions which are specifically targeted at broadband, fixed broadband, and on the mobile and 5G sides. And nothing succeeds like success, as it says. So luckily, we have had broad adoption of these technologies across tier 1 service providers. Comcast, Deutsche Telekom, Turk Telekom, Telefonica, AT&T have all taken this bold moves towards productization of these projects and have deployed this, and we'll hear more about it from Robert very soon. There's active interest from many other operators around the world, British Telecom, Liberty Global, NBN, Telecom Italia included. On the mobile side, we also have Deutsche Telekom, T-Mobile Poland in production with open access, the open core, LTE core, and pilots for the connected edge cloud as a service platform, Ether, are happening as we speak. But let's come back to fixed access and wireline broadband. Over the past 24 months, SEBA platform, which is the platform which exemplifies the fixed broadband, has been hardened by ONF and the active community, and it's already being scaled for production for use by suppliers like Netsia, Redis, and others. And you can hear more about these solutions by going to our website and hearing their talks. Let's briefly dive into this platform that holds the key to unlocking that 1 trillion opportunity I talked about. ONF operators, partners led by Deutsche Telekom, AT&T, Turk Telekom have inspired ONF-led community to reimagine the PON infrastructure by disaggregating and SDNizing the closed integrated solution on the left. The SDN-enabled broadband access SEBA reference design was published in March 2019 and is available from ONF's website. It defines several key control components of PON infrastructure being implemented in software following the SDN principles, while data plane primarily the hardware plane. The reference design has been implemented as open source platform. We call it the SEBA Exemplar. This is ONF's flagship open source platform for fixed broadband and is the successor to the RCORD platform. As you see, it is composed of several key open source components also developed by ONF over the years, including ONOS, Volta, NEM, and all of this work on OCP compliant white box hardware, both switches, OLTs, and servers. You can visit our website to learn more about SEBA and Volta. And there are many technical talks on YouTube about these platforms, which you can also peruse at your convenience. So let me highlight the documented impact SEBA platform is having on delivery of broadband. Softwareized and programmable infrastructure enables deep automation and efficient use of shared platforms and components. ONF's cloud-inspired innovations like CI/CD, A/B testing, etc., bring service delivery agility to telecom operators. And an important study done by AD Little with the help of Deutsche Telekom, AT&T, and Telefonica showed exceptional economic benefits. 40% CapEx savings, 25% OpEx savings, and about 5 to 11% incremental revenue potential by using this architecture. In summary, in my view, holds the key to unlock this opportunity to correctly future-proof broadband infrastructure and making the most out of the crisis we are facing. The SEBA platform gives industry a near production-ready open platform, attractive economics. Tier 1 operators and dynamic new suppliers are leading from the front and helping substantially reduce the market and technology risks for adopting this approach. And with that, I want to thank you and invite Robert to talk about the DT journey in this process and where they are.
Thanks, Aseem. Thanks a lot for the presentation. And I'm also, I also want to mention that we are very proud to be part of the ONF community. And we thank the thought leadership that ONF has put to the community in the last couple of years. I want to talk today about Access 4.0 and our, so to speak, SEBA incarnation. Aseem was just talking about the Exemplar. DT has a very similar approach. It's almost the same. We especially use Volta as a key component. And I want to talk about what we do, why we do it, talk a bit about the ecosystem, and of course, our timeline. Just to give you the context, DT has already a network out there. We mainly serve our customers using FTTC. We have, like most of the telcos, certain central offices, and core central office re-architected is about, reusing the central office with mini data center technology. And this is exactly what we do. So where we have today the BNG, we will reuse those locations where we have the BNG and put a mini data center in there. The Access 4.0 mini data center. The customer at the end, on the left-hand side, should not perceive any change in product. The customer shouldn't know that he is produced by Access 4.0 or instead of the BNG. That is our goal. But from a topology perspective, we are reusing exactly what we have, also with a handover to our wholesale partners. However, initially we will focus on FTTH, on the new fiber coming just a little later. And in later phases, we talk about FTTC and business production, where we have especially point-to-point fiber connections. So what does this mini data center look like? Yeah, because it's about disaggregation. The picture seems a bit exploded. The centerpiece, at least from a hardware point of view, is this leaf-spine fabric. And the leaf-spine fabric, again, this is something that you find in any data center of the world. This is how you scale east-west, since it is 90 degrees diverted. Yeah, it is north-south in this sense, but we're talking about east-west scalability, and this is one of the benefits. So we talk about disaggregation. So what was a BNG box before is now a leaf and a spine. Well, how did we come up with this design? Well, we thought about, well, we have to aggregate ports, so we need a leaf spine fabric to, do the scale and collect all the traffic. And then we thought, okay, well, there is those chips in here where the data path needs to pass through anyhow. So we leverage it together with our partner RT-Brick to bring the BNG functionality directly into this leaf spine fabric. That's number one from a technical point of view. The leaf becomes the service edge or the handover point, the so-called A10 NSP for our wholesale partners. The spine, in fact, is not just aggregating traffic or forwarding from one leaf to the other. It is also the forwarder to the IP core, bearing the label edge routing functionality. The heart, though, because this is not just about disaggregation, it's also about softwareization. And the software is put on a mini data center, on a little cloud, so to speak. We have a Kubernetes running on just 3 servers, because we believe that 3 servers is absolutely sufficient to power such a mini data center. And this is where we have the cool services. First of all, Volt HA, as Aseem mentioned already in his previous presentation, to power our OLTs. And we as DT are absolutely convinced that this part must be a community project, because we do not want to debate with vendors about drivers, about EMS systems. We want to say, okay, look, vendor, if you want to come into our network, this is Volta. Just take it from the community, and you can integrate your boxes in there. So one of the microservices that is up and running here is Volt HA to power all the OLTs, be it GPON, be it XGS-PON, be it a combo device whatsoever. Then, of course, we have a component that is an SDN controller. It's our own development to solve our own problems at DT, but I believe it will also solve other carriers' problems. This is how we can have multiple service edges in one go. So actually the packets are detected from the customer, and with a certain functionality, the customer is forwarded to a service edge where his or her service is terminated. This is a real cool functionality and bringing us away from the monolithic BNG architecture that we previously had. There's plenty of videos which I can recommend on both the SDN controller from Fabian Schneider, on the BNG from Hans-Jörg Kolbe, and on overall architecture from Thomas Haag, which you can find on the internet in the context of the ONF. I would love to continue with, just this very simple message. We have a central instance, which I didn't talk about, that could be referred to as the central EMS, element management system. Yeah, it is a very simple and stripped down version of it. It's also running on Kubernetes. It's also containerized, just modern IT infrastructure as you would design if you would build up your own data center today. And then from there, we have around about 1,000 Kubernetes clusters running across Germany. That's the plan for go live and for future rollout. But to stick with the picture, what does the ecosystem look like? And here we are coming already to the why to some extent. Yeah, this aggregation helps, of course, to bring in new vendors into the ecosystem. As I mentioned already before, we can leverage cloudification infrastructure that are across several used across several industries. So I'm pretty sure that in aviation, in banking, assurance, or automotive, sorry, Kubernetes and Linux are used, yeah, no doubt about it. We use hardware that we could use from the OCP or the TIP project. Currently, we are working here with Adtran, but we are also in very close sync with EdgeCore and Delta, yeah, new kids on the block, and that is very important. We talk to virtual BNG vendors. This time we have decided for RT-Brick, but we are also looking for second vendors, and the ONF is heavily working on an open source implementation. Once this is ripe, we may change or we may add in a second vendor. And as I mentioned earlier before, the driver of the OLT, which was previously proprietary EMSs, is now a Volta. And this is really cool because it helps us to keep costs at bay. And since I've covered already a lot from the what about the why we do those things. I mean, this aggregation per se is not a value. First of all, you break things apart, which make it much more difficult to integrate. But we believe that we can save cost, and this will help also us as technology department, but also our procurement to negotiate better prices. Imagine a shelf-based system where you had line card. If you have line cards, yeah, when you talk about, you know, extending your network, you can only talk to this very vendor. Breaking up things in, bring also at a later life cycle stage, brings in new vendors, new hardware vendors, or new software vendors. So one of the major topic we wanted to pursue, and we still pursue with Access for the Door, is to break the vendor lock. Softwareization, yeah, we often compare ourselves to the Amazons, to the Googles, but how can we become as agile and flexible if we do not embrace the software principles? I talked a lot about Kubernetes, containerization. Yeah, this will help us to really turn around very quickly in terms of time to market and to embrace real DevOps with CI/CD and to really build, plan, and run our network with a fraction of the workforce of today. Another big headache was the tight integration of OSS and our network technology, the so-called NT technology. Perhaps this is a specific problem to DT, but I know a couple of other operators facing the same challenges. This was always a burden on time to market. We have now separated the production and the process IT with a clear limitation, which will help us to accelerate things and churn out new products for our customers in a fraction of the time of today. And last but not least, I mentioned already the SDN orchestrator. Let's put it like this, the POW, the Pod Access Orchestrator. This is code that DT is willing to share. We will not bring it to the open source, but we are willing to share. So please feel free to reach out to me. We want to share not just with operators, but also with integrators. We are happy to do so. But this multi-service edge architecture really helps us to get away from the single service edge where we have business, retail, and our own DT retail customers on one and a single box. And if we want to change something, we have to change the software for each and every one. So these are the primary motivations. And I'm the project head for already 4 years, and we still hold those benefits and those things that we strive for. We hold them dear, and we still work every day to make this possible. And our timeline looks like this. We want to go live, after 4 years of intensive, development, finding out what is feasible, how we can actually integrate it in our network. We want to go out by the end of this year. And you may look at my face, yeah, I'm looking tired already, but there is still, 2.5 months to go until we can actually go live and connect the first customers in the southern Stuttgart area where we want to go live with FTTH. And the idea is really to have our friendly retail customers, DT customers, bringing up fully automated on this new access for the door design. In the next quarters to come, we will also go live with wholesale. We will scale the system, make it ready for layer 2 wholesale, and deliver the final MVP through the course of 2021 with FTTB. So this is the consumer approach, and by the end of 2021, we also want to have the first business technology up and running. And I'm happy to take your questions now. Thank you very much for listening.